All right. Hello, everybody. Welcome. If you're joining us, feel free to say hey in the chat. And if you want to, feel free to say where you're from. Hey, Maddie. Welcome. Happy Friday. Hopefully that link down there will work for you. Martin, how's it going in the Netherlands? Thanks for joining us.
All right. Hello, everybody. Welcome.
Ooh.
If you're joining us, feel free to
Let's
say
see
hey in
if
the
I've
chat.
got
If you want to, feel free to say where you're from. Hey, Maddie.
oh, hang tight. I got some feedback for some
Friday.
reason here.
Hopefully that link down there will work for you. Martin, how's it going in the Netherlands? Thanks for joining us.
Let's see here.
Welcome.
Hey, everyone. If you're hearing that feedback, hang tight. I'm dealing with it right now. All right, there we go. So learning quickly here. Don't have the live stream open in your background or that will cause issues. So we're all good now. Hey everyone. Eisen from Mexico, welcome. Thanks for joining us. Shahar from Atlanta, welcome. Glad to have you. How's it going, everybody? Happy Friday. Sahad from Kashmir, welcome. Chaim from Israel, welcome. Glad you could join us. Let's see if I can mute this guy here. All right. Welcome, everybody. We'll give everyone just another minute to join in here. Right. Mikhail, welcome. All right, everybody. So, welcome to episode 78. My name is Josh Rosso, and I am on the same team with Duffy, and I also work with Joe. I came over to VMware from the Heptio acquisition, so I'm so happy to have you all here, and thanks for humoring me in my first TGIK here. Hopefully we're going to have a good time talking a little bit about pod security policies and diving a little bit into that. So getting rolling here, let's start with our HackMD, and we'll talk a little bit about some of the news in the Kubernetes ecosystem, and then we'll get right into the content. So again, my name is Josh. You can find my handle in the HackMD here. I'll put the HackMD link inside. All right. So, a little bit about what we're going to be covering here today. So obviously our focus is pod security policies, but there's a couple things that I want to just talk to you all about as far as news in the Kubernetes ecosystem. First off, you might have noticed we are officially in a different channel. So we have a new channel. Please, if you haven't already, subscribe to this channel so that you can keep in contact with all the TGIKs that we're doing and that you don't miss one. So don't be thrown off by the new channel. We'll be posting from here going forward. All right, probably the most exciting news that we have this week is that Kubernetes has officially reached 5 years old, which is super exciting. So it's kind of interesting if you think about it, right? You know, when you started your Kubernetes journey, some of us have been here for just a couple months. Some of us have been here for a year plus. Some have been here, for many years. So it's really exciting to see Kubernetes hit its fifth anniversary right after KubeCon here. So really cool. All right. Some other cool links. There's a really cool post on Medium talking about how to set up a serious Kubernetes terminal. So if you get a chance to check this out, it's got some really cool tips and tricks around some kind of interactive tooling that you can use to analyze, look at, interact with your Kubernetes cluster, which is really exciting. And probably another big item to talk about here as well is our Kubernetes versions have changed. So We had 3 releases based on a security issue, so if you haven't already checked those out, please do. 1.14.3, 1.13.7, and 1.12.9 have been released. Even in this session, I unfortunately won't be using the newest version, but those versions have come out, so please be aware. Another cool post as well. There's a article on Medium. Oops, sorry, clicked the wrong one there. Let's go back. Sorry, not on Medium, but on IT Next through Medium. Boosting your Kubernetes productivity has some really cool tips and tricks around kubectl, doing different types of completion, easily switching between namespaces and contexts. So please be sure to check this post out as well if you want to get a little bit more savvy with some of the kubectl interactions that are out there. All right, and then just a couple more real quick. The Certified Kubernetes Administrator Cert is now good for 3 years. So those of you who do have your CKA, be sure to check that out. The cert is, again, good for 3 years now. KubeCon Barcelona has just finished, so that's also really exciting news. We're all kind of perhaps a little bit jet lagged still, although it's been a while getting back from KubeCon in Barcelona. So hopefully some of you were in Barcelona. And good stuff. Another cool thing is Tim Hawken did an Ask Me Anything, so please do check that out as well. Inside of the AMA, you should be able to kind of get an idea of some of the questions that Tim had asked and the answers that people had posted as well. So overall, really cool stuff in the news this week. Again, major things being KubeCon's over, we're all back. Kubernetes turned 5, and we have a couple different releases based on some small security things. So that's about it. So we'll get right into it here. Let's see who else has joined. Sergey, welcome from Russia. Glad to have you with us. All right. So what we're going to be getting into today is talking a bit about pod security policies. And around pod security policies, I first just kind of want to poll the group here. In chat, go ahead and tell me whether you have PSPs being used in your clusters or not. So say yes if you're currently using PSPs, and say no if you're not, just so I can get a kind of an idea of the room and what people are considering. So again, yes if you're using PSPs, no if not. So pod security policies are something that we work with a lot of our different customers around, just kind of walking through setting them up, kind of conceptually understanding how the different pieces fit together. It's a little bit challenging conceptually to dive into this area of pod security policies and how it kind of changes your structure of how things work inside of the cluster. So cool. So I can see it looks like we got a mixed group here. We've got some who have PSPs on, a lot that don't. So those of you who don't, you're going to get some good perspective here on some of the things that it can impact. Looking good. All right. So the first thing that I'm going to kind of start off with as we conceptualize about pod security policies is try to show you a little bit about why these policies are important to consider. Okay. So I'm going to start off with a really simple cluster, and this cluster is going to have a master node and a worker node that are running. So nothing too special, one master, one worker, okay? So inside of the master node, let me go ahead and switch to my screen here. All right. So inside of the master node, we have no pod security policies turned on whatsoever. So this is a pretty standard cluster that you've got here. I've got just the kube control plane components running and core DNS and Calico. So Calico is my networking CNI and core DNS is my DNS server, obviously. So what exactly how does a Kubernetes cluster behave out of the gate when you're doing this kind of stuff without any pod security policies enabled? Well, it basically means that for the most part, you can almost do anything with your deployments, right? You can take a manifest, you can drop it into the cluster, and it will instantiate and create that pod for you on your behalf, right? So an example of this, if I wanted to run an Nginx pod, nothing too crazy for most of you. I'm sure many of you have used Nginx as kind of your default app here. if I go into the App Pod for Nginx, all right, so we've got a very simple pod structure here. Our labels are Nginx and Team A, and our container is just gonna, for the sake of example, just run off of Nginx latest, right? So applying this should theoretically instantiate the pod. All right, so let's go ahead and set this up here. So I'm gonna pop out of this window. All right, we'll do an apply for the Nginx app pod, excuse me. And down here in the bottom, we'll set up a little watch just so you can kind of see what's going on. So if we do a watch for the kubectl get pod namespace org1, actually I've got an app running inside of here because I was playing around a little bit. So let me delete that real quick. So delete the app deployment. All right, cool. And we'll get rid of those, and let's just focus on our app pod at first to make sure it's a little bit simpler. So we'll do apply, okay, of our app pod.yaml. Awesome. All right, so as you would expect, this is going to create an Nginx container, and this Nginx container is running inside of the pod network. It's working just as you'd expect, okay? So if we wanted to do more, how do you say, maybe things that we shouldn't be doing with the manifest, it really wouldn't be hard for us to do. So theoretically, we could come in here to our pod and say we wanted to go into the Kubernetes cluster and start kind of launching workloads inside of the cluster from within a pod itself, okay? So kind of giving you an example here. So if we go into pod, particularly our app pod.yaml, all right? And let's go ahead and just change this up a little bit, all right? So we'll come down to containers here, and we'll set up a section for volumes, okay? All right, so volumes, good. And then inside of our container itself, we're gonna put in a section for volume mounts inside of here, all right? So that all looks good. Now, inside of our volumes, we're gonna have one that we've named, let's say bad, inside of here. And then I'll double check on the syntax here, but I think we're gonna have a, let's see here, a volume mount. So the volumes should have a name and it should have a mount path. So we'll say, actually this will be in volume mounts, excuse me, getting my, my schemas mixed up. So we'll have a mount path here, right? And the mount path is going to be inside of the root directory called bad, right? And volumes themselves should also be an array. All right, so we've got mount paths mounting into bad, and we're gonna go ahead and set up the mount to the volume bad inside of here. So this volume mount is going to bind into this volume right here, all right? So what we can do now is, since we don't have any pod security policies in place, effectively, we should be able to mount anywhere in the file system that we want to, which you could probably guess why that's probably not the best thing, right? So inside of volumes for host path, we've got name. This is going to be the host path. Our path will be a path for etc Kubernetes Manifest. Okay, so we'll push this inside of the manifest directory. And then the type is, of course, this is a directory, so we'll go ahead and call it directory, right? So we've got our path set up, we've got our type directory set up, and it's all inside of host path for the name bad. Now, chances are decent that I've got some schema issues here, but let's see if I can find any potential issues with volume. So I'm going to delete that pod here, and we're going to go ahead and apply this newly set up pod that again has the host path in it. So let me make sure I get the right app here. So app pod, there we go. We'll delete that. And in the bottom of my screen here, you can see that that app is now officially deleted. Okay. So with this setup, we'll see where my typos are, right? We'll do an apply. Okay. Oh, sweet. It worked. It's rare that that happens, but it did work. So again, theoretically, what we've got here is we've got a volume mount that's set up. to effectively write any data that we want inside of this manifest directory. So again, keep in mind that like these hosts in Kubernetes, they're multi-team, potentially even maybe multi-tenant perhaps, where you've got many different workloads across different namespaces, perhaps running on the same host. So to kind of hop into an exploit here, now that we've mounted this in place and there's been nothing to stop us in our manifest, we should be able to go into this pod and start doing some fairly bad things, right? So as an example here, I'll pop one window over and I'm going to open up 2 buffers, okay? So again, we have got a pod. So let's do kubectl get pods for the namespace org1, which is where our pod's in. So our pod is called team A, right? Let's go ahead and exec into that team A Nginx container. So we'll do a kubectl exec into the team A, again in the namespace org1. And this will be an interactive exec where we open up a bin bash process, okay? So now we're inside of the container. As you can see, there's a couple things here that are probably a little bit concerning for those of you who are a little bit more security minded, okay? First off, you'll notice I'm running as root in the container. Now, I'm not outside of the container. I'm in the actual container running as root, which still is less than ideal. And I'm at team A, which is my host. So if I go into this, this root path, if you will, let's just do an ls, you can see the standard kind of Linuxy file systems in here. And you'll also notice that I'm mounting something called bad, all right? So something in here is named bad. So like any good person would, we'll cd into bad because that's what you do. And now that we're in the bad directory, I'm going to SSH into the host. Now, because I've only got one worker node, I know that the KVM-based host here is running on 202. So I'm going to go ahead and SSH into it, log in, all right? And if I sudo in and go to etc Kubernetes Manifest, I'm now in the manifest directory, okay? And we'll set up a watch here. So let's do a watch ls on this manifest directory. Now, etc Kubernetes Manifest, depending on how you install your clusters or set them up, it may or may not be something you're used to. Without getting too much into the details right now, this is a directory where we are able to put something called static pods. So by putting a manifest in this directory, if static pods are turned on, the kubelet, without having to talk to an API server, will actually be able to instantiate that container and run it on the host. So those of you who use things like kubeadmin to bootstrap your clusters, you're actually using static pods behind the scenes in most cases to instantiate those pods and actually run them, all right? Now, again, I've got this container and I've got it mounted into this etc Kubernetes path. Now, if we just hop on the internet and we type in, let's say we do pod example, let's say Kubernetes pod example. Let's do that, all right? And let's say pod example YAML maybe. Just want to get some random pod off the internet here. Okay, so Kubernetes, let's see here, MySQL pod. Actually, you know what? There's one that I was using earlier called Croc Hunter. Let's see if I can find that. Okay. All right, perfect. So I've got this pod. Let's see, Croc Hunter. That's the chart. Let's see here, Croc Hunter. YAML pod example. Here it is. Okay, great. So I was looking at this pod just earlier today when I did the same Google search to see what pods would come up. So I'm just going to go ahead and grab this manifest, this pod manifest from this URL. All right. And now if I go back to my host, again, in the top window, I'm in my pod, and in the bottom window, I'm on the host. Now, I'm going to go ahead and install wget on this because this pod should have egress capabilities. So I'll do a quick apt update. And I should have baked the image, but that's okay. We'll do an apt install wget. So we have wget. All right, looking good. And then once wget is installed, we're going to download this pod. So if I do a wget for this Croc Hunter pod, it puts it in this directory on the host in the bottom of my window here. Now again, since this is a static pod directory, the kubelet isn't concerned about talking to the API server about information about the pod or where it should go, right? So if I back up here and just do a quick, let's cd back to root here, root's home directory. If I do a docker ps for, let's say, well, Croc Hunter, I guess, you can see that Croc Hunter is now running as a static pod in this host. I didn't have to use kubectl. I didn't have to do anything special. I just had to mount into this directory and drop it in. And Kubernetes aside, right, if you had the ability to do this, if you're using something like Ubuntu or some Linux operating system that has like a pre-start or a start directory where you can drop different units or things in to start up on startup, or to boot on startup, if you will, you can effectively take advantage of this and start having things and processes kind of boot up and start as well. Now, an interesting thing about this, and I want you to kind of hold on to this little nugget for a second here. An interesting thing about this, if we leave our terminal, is if you do a kubectl get pods in the default namespace, Croc Hunter will technically show up, okay? But that doesn't necessarily mean that Croc Hunter is being managed by the Kube API server. We'll talk a little bit more about that for now, but for now, we're going to call this something called a mirror pod, all right? We'll talk more about it later, but suffice to say that I've inserted a pod or a container into the system, and I've effectively been able to do something like this, right? So you can see how from a multi-tenant environment, this could be really problematic as people could get into the host and do bad things like this. Now, what I'm going to do to kind of keep things simple here, I'm going to leave the container, and we're going to go back to the host, all right? And in this host, oops, let's get back into it. In this host, we're going to just clean up that directory here, all right? So we're just going to go back to etc Kubernetes Manifest and delete that. So etc Kubernetes Manifest, and we will delete the pod example to make sure it goes away, all right? Okay, so this is an example of how, from a file system perspective, having no real enforcement on the pods that are being created is going to enable you to do some potentially bad things. Now, here's another example for you too, just to kind of drive this home, and then we'll talk about actually implementing the PSPs and what exactly they look like, all right? So if we go into the app pod one more time, let's bring ourselves back to where we were. We're going to take host mounts out. We're going to take volumes out. All right. Now, this cluster is running with Calico as its CNI plugin. And Calico is going to allow us to put a bunch of network policies in place so that we can restrict traffic in the cluster and make sure that every pod can't just talk to every other pod, or perhaps certain pods can't go outbound through egress and so on, right? As an example here, if I just bring back up this bottom window, if I do a kubectl get global network policy, all right, I have this Calico CRD called global network policy. And if you're not super familiar with Calico, suffice to say that this is telling the cluster to lock down all traffic by default, except for the CubeSystem traffic and traffic to DNS servers. Everything else I lock down by default across the cluster, all right? Now, org1, if we look inside of it, because technically we shouldn't have been able to do like apt update and things like that, right? So if we go inside of here and do kubectl get network policy, and these are the standard Kubernetes network policies. They are namespace scoped. So if I ask for the one in org1, I have org1 set up to have an allow all egress policy. Now, I'm not going to show you the policy itself because this is not about network policies, but you kind of see where this is going, right? The whole cluster is locked down by default, and then someone went into this namespace and set up a rule that allows all egress traffic right out of the gate. So, hypothetically here, let's say we wanted to remove this. Any app that runs inside of the TMA namespace, we no longer want it to be able to egress by default. So let's do a kubectl, and we will delete this network policy. So delete network policy inside of the namespace org1. All right, so now it's deleted. So in a theoretical world, if I go out and redeploy this Nginx pod, I am not going to be able to do like an apt update because it's just going to freeze and be blocked by Calico from getting extra traffic. So let's try that real quick. I have the app pod up here. let's go ahead and watch our org1 namespace in the bottom. So I've made some changes to it. We will start off by deleting it. So let's delete that pod, take it out of the equation. Okay. And then let's go ahead and apply this pod right back. Again, I've taken out all the volume mount stuff, so we're just focused on network traffic now. So I apply this pod. Container goes in and it creates. Same idea. If I come down here, I should be able to exec, let's clear this out. I should be able to exec into that same team A container under bin bash. So we'll go ahead and enter that. Now, if I do a apt update, you'll notice, depending on your familiarity with apt, I did, through DNS, resolve deb.debian.org. It resolved to this IP address. However, I am being blocked, which might actually be a desirable behavior of your network. So again, this is a namespace where you want to run a bunch of workloads where those workloads cannot egress outside of the cluster. It is completely locked down for egress traffic. Now, we don't have pod security policies in place. So getting around this model is pretty trivial. If we leave our container, again here, set up a watch one more time. All right, I'm going to bring it down a little bit. All right, so some of you probably know where I'm going with this, right? What could we do here to effectively bypass our network policy altogether? Well, if we go into our containers here, we could set up host network equal to true. Now, there's a lot of reasons why we don't want to set host network equal to true, but especially for user workloads, that is. There are some exceptional workloads like perhaps the Kube API server or perhaps your ingress layer where actually binding to the host network might make sense. But this should theoretically block us or allow us to get past that block, this host network. So if I save up host network here and I go ahead and apply this pod, let's start off by deleting it. Okay. Cool. And then we'll go ahead and apply it again once it terminates. Apply that pod. All right, it is created with host network. Now, again, without any PSPs in place, it was one line, line 15. This is all it took for me to change effectively the network security model of my running pod, right? What do I mean by that? So check this out real quick. First things first, there's no network policy that's allowing egress. So if I exec into team A, I shouldn't be able to do an apt update just like before, right? So let's go ahead and exec into team A. All right, we'll exec back in. Now, if I go and I do an apt update, I'm able to access the external internet regardless of what my network policy is, because I'm now bound to the host network. Another interesting thing I can do, for those of you who are used to like how the IP tables mechanisms work and things like that, theoretically, I can not only leave the host network, but I can actually access potential things in the service network inside of the cluster as well. So let's say, as an example, I go in and I do a, let's see here, a kubectl get service for the namespace org1. Okay, I've got this team A cluster IP that fronts the pod. So this cluster IP is an internal virtual IP that shouldn't be exposed. And theoretically, I can go in with this pod that's now allowed to egress, and assuming I do a install of curl, so let's go ahead and get curl on this host real quick in the bottom. So we'll install curl. I should be able to access this service IP because I'm on the host itself. It's almost like I'm some root process, or at least some process, not necessarily root, that's running and able to access things. So if I do a curl to here, boom, I've got the Nginx 404 page. So now I can access these internal service IPs, even though I should have been blocked by egress. And then lastly, of course, and I promise this is the last example of this, since I've bound to the host, not only from like an internal security standpoint is that concerning, but I'm on host network now. which means that my random workload has bound to port 80 on that host. So if we think about this, we know that it's running on 192.168.0.202. That's my worker node in this cluster. And if I curl that on port 80, I also get the Nginx page. So I have taken my internal pod, which I would potentially expect to run only on an internal pod network and have to go through a whole layer of ingress and other things, and I've effectively exposed it on the edge of this host. So this shows you how, with these minor modifications, you actually have the ability to do some pretty serious things in a cluster that could be multi-team. All right? So this is where we're going to start talking about pod security policies as a whole and how they work. All right? And it feels a little bit tricky at first. You're right, to be frank. It's pretty tricky conceptually. At least for me, it was hard to really get an idea of how these things work. But effectively, when somebody puts something like host network in, when somebody binds to a host path, we want to stop that before the pod itself gets created. Okay? Now, as you know, there's no pod security policies that are on by default, which means we need to enable pod security policies on the host itself. All right, so I'm going to switch over to the host and I am going to show you how to flip that on. I'll take a quick look at the chat too. Olav, welcome from Denmark. Glad to have you. Timmy, welcome. Kausik, great to have you. Welcome, welcome. Thanks for joining. Cool. All right, so let's go back and we are going to SSH into the master node. So again, my worker node is 202. My master node is 201. So let's SSH into the master node here. And now that we've shown an example of this, you might have a pretty good idea. With kubeadmin, which is how these clusters were stood up, I am able to go in and edit the API server. So to do this, I need to sudo vim etc Kubernetes Manifest. This is going to be the location of my API server manifest. And I'll do a kube API server here. Okay. So kube API server.yaml. All right. So this is my static pod. When the kubelet turned on, it saw this manifest in that directory, and it just started the kube API server. Now, what we need to do here is we need to look for the line where we can set enable admission control plugins. All right. There was an old flag here that had a slightly different name, and that flag order did matter. This one, if I recall correctly, it doesn't actually matter. So all we need to do with this is we need to append on pod security policy to the end of this, right? So obviously, you're probably going to do this with your automation. Perhaps you're going to have Ansible change this, or perhaps you have some type of distribution of Kubernetes where you can flip this on as a default setting. But we're going to flip this on here and see how things change. All right. Now, I also want to show you before I save this up, I'm going to go ahead and set up one more watch down here. So let's do a kubectl get pods in the namespace CubeSystem. All right. I'll make that a little bit smaller. So this is my set of CubeSystem pods, all right? When I save this, the behavior should be that the static pod restarts itself and the API server goes offline temporarily and comes back. So ideally, I have a highly available control plane so I can make changes like this, and the load balancer will automatically know to not send stuff to that API server while it's restarting. So let's go ahead and save this up and quit. And in the bottom buffer here, you can see my API server has officially gone down, and it is going to be coming up. All right, so I'll check the chat while that's coming back up. Koslin, welcome. Mert, yes, I am using a standing desk. I'd be very talented to move this quickly in a chair. Or it'd be a very rolly chair, I guess you could say. But yeah, I am at a standing desk. All right, so my Kubernetes API server is coming back online and my pods are now running again. So we flipped pod security policies on. Okay, now, if those of you who said no in the chat to never running pod security policies, I will tell you what I just did is usually what messes people up out of the gate when they first do pod security policies, okay? Because you go, okay, well, I need pod security policies, so obviously the first thing I'll do is I will turn them on, all right? Now, I'm going to go ahead and let me just make sure, because I was playing around with my system earlier, let me make sure I don't have any pod security policies. So get PSP, I do have one. Let me delete this PSP real quick, just so I can show you what it would normally be like. Okay, cool. So we're back to normal. I have no pod security policies in my system, but I have turned pod security policies on. Now, by default, this will sort of hose you, right? This is going to put you in a place where you're super fragile, and if a pod needs to restart, it might not be able to. It probably won't be able to. So let's use an example. So we're looking at our system here. Let's use Core DNS as an example. So Core DNS runs as a deployment. And if I delete this Core DNS pod, it is the job of the replication controller. The replication controller who handles the deployment is the job of the replication controller to make sure that the pods are instantiated in its control loop, ensuring it has the amount of pods that you expected, right? So let's do a kubectl and let's delete pod, all right? And if I delete Core DNS here inside of the namespace CubeSystem, and now I'm obviously deleting this, but those of you who've been using Kubernetes, you know pods get started and stopped all the time. So this doesn't have to be me. This could have just been servers moving around or a scheduling event that needed to trigger. Like this is just something that happened in the cluster without intervention, although I'm proving it via intervention. So if I delete this pod, the pod terminates and it goes away eventually. And we should still have one of two Core DNS pods running inside of here. And now we do. But again, based on what I told you, assuming I'm not lying to you, we should have had a Core DNS pod replace this one because the replication controller should be instantiating a new Core DNS pod. So let's check this out and see what it means real quick. So if I do a kubectl and I'm going to get the deployment, if you will, for Core DNS, inside of the right namespace though, for CubeSystem, all right, so I've got Core DNS. I've got a ready one of two. Now, one thing that we'll oftentimes check is we'll want to see the events of these constructs and see if there's any events that are interesting that might have given us some details. So if we do a get events for the Core DNS deployment in the namespace CubeSystem, let's see here, get events for, get events, my bad. I meant to do describe. Sorry, not get events. I can get events for all of them, but I'm just going to describe the Core DNS deployment. So let's do deploy for Core DNS. All right. Now, if I look closely in this window here, there's no events that came out of this particular controller, which is what I'm mostly interested in. But I do have a little bit of information as I'm debugging. I'm trying to figure out why the heck has Core DNS just disappeared? Why isn't it being created? Well, I can see that I have some type of replication failure condition. All right. And based on this, I know that Core DNS is being managed by this replica set right here. So the problem isn't necessarily going to surface on the deployment, right? It's actually going to surface on the controller, which is the replica set that actually owns the instantiation of the pod. So let's go ahead and do a kubectl get replica set for Core DNS. All right, and I'm going to go back to CubeSystem here. And get rs, CubeSystem with an M. And same idea, we've got two desired with one current, all right? So let's describe this. If we do a describe replica set, now the replica set itself, it does have an event. Now while it's wrapped around, hopefully you can kind of see it here, it's telling us, zoom in a bit, it's telling us, warning, I failed to create via the replica set controller, the pod Core DNS with the replica set prefix. And it's telling you it was forbidden, right? Particularly, it was forbidden because there was no providers available to validate the pod request. So what does this mean? Some things to kind of know about pod security policies here that are really important. And I'm gonna pop open a little little note window, if you will, and we'll keep track of some of these key gotchas with pod security policies, okay? And we'll put them in the HackMD as well. So some of the key gotchas, right? So when PSP is on, pods created must resolve against an existing policy. Okay? So when PSPs are on, the pods created must resolve against a existent policy. All right? Now, if we kind of think about the flow here for just a moment in regards to what's happened, we've basically got this situation where we had the replication, or sorry, I guess the replica set controller, right? It wanted to create a pod, right? So what happened between the replica set controller and the ideal creating of the pod? Well, the replica set controller talks to the API server, right? So the replica set controller went into the API server, right? And it wanted to create the pod by asking the API server to create it, right? But inside of the API server itself, if we kind of break this down for a moment, the API server had a kind of a chain of things it did, right? It went in and it auth-end/auth-z'd the replica set controller. Okay, so that's one of the first things that it did here. And then it passed that through the pod security policy admission control. So we'll just say admission controller. In this case, PSP, or potentially any other admission control. So when the replica set controller went in to create that through the API server, it got blocked on this command right here, or this call, because the admission controller blocked us and said, no way, you're not creating this pod. You don't have a policy to validate against. You have to have some policy in the system itself. All right. So now it's time to kind of talk about how we can get the actual policies themselves created so we can bring our cluster back into a state where pods can be restarted. We can create new pods. As another example here, I'm going to bring these notes back in a sec, but let's go back to our original example with Nginx, right? So if we do a kubectl get pods for the namespace org1, we still have team A. So let's go ahead and delete that pod. All right, so this will be for team A. Looks good. All right, cool. And then I'm going to go ahead and apply this particular pod. Now, as a user, I'm just like the replica set controller here, right? I'm just another, let's say I'm just another account as far as the API server is concerned. Same idea. It said, hey, I can't create this pod for you. There's no PSP for you to actually use, all right? So now we have to get the actual policies in place to make this work. And as you had seen, if I do get PSP in my cluster, I've currently got no pod security policies in the system. So what kind of policies do we actually want to make this work? All right. So if you kind of think about the landscape of your apps for a moment, all the workloads that run in the cluster, let's do a kubectl get pods for all namespaces. Okay, so kubectl get pods for all namespaces here. Make it a little smaller. All right, so this is everything that I have running right now. But normally I'd have a bunch of pods outside of CubeSystem that are just like user workloads. And what's going to end up happening here is I'm going to want to be able to provide kind of like a level of policy that just general purpose workloads can use. But I'm going to want to be able to provide heightened policies, or I guess more permissive policies that my CubeSystem components are able to access, and perhaps even other namespaces that are privileged, if you will, based on system components and things that you have. Okay, so let's say, for example, there's kind of like a default policy that we want to use. Okay, so first thing that you're probably going to have to do is hop into the Kubernetes Docs. Okay. And learn a bit about what these pod security policies are, in particular, what some of the different parameters are that you can turn on and off. All right. Now, I'll be honest, when you're first getting into this, it's a bit arduous. And I'm going to show you a really cool tool by Sysdig towards the end of this that makes this a lot easier, or at least can help get you started. So more on that to come. But for the time being, it can be a little bit challenging, to say the least. Okay. Inside of the documentation, they do have some examples, if I can find them here, permissive and restricted. Let's see if I can find it. Okay, cool. So inside of the docs, you'll find some restricted examples, and you'll find, sorry, not permissive, but privileged examples. So the Kubernetes docs by default usually have you put in a privileged PSP, which is, again, kind of like those CubeSystem-like things. You're allowed to use host ports. You're allowed to use host PID. You can run as any user. But if we go down to the more restrictive policy, there's some more constraints. For example, in the list of volumes, you'll notice that you're not allowed to mount a host path. You'll notice that your user in the container must run as a non-root user. So these examples in the docs are actually a really good start. I'd argue that they're probably more permissive than you need them to be, depending on how tight of a ship you need to run here in regards to some of your kube components. And I'll give you an example of that. So if we go back up to the privileged policy for a moment, one of the things that you'll notice is that we are allowing all capabilities. We're allowing privilege to run as privileged and so on. Okay. Now I'm going to show you just a slightly modified version of this policy. Okay. So if we go back and look at policies, I have a policy that I usually run, or at least I kind of start people off with, that I call the CubeSystem PSP. And up for debate whether that's a good name, because you'll learn how PSPs themselves aren't namespace scoped, which is something we'll talk about. They're globally scoped, and we kind of reference them with namespaces. But I do call this one CubeSystem because I like to scope it to CubeSystem itself. And I'll kind of show you how that works in a moment. But let's look at what the CubeSystem policy is, okay? So if we ignore all this stuff at the top and just focus on the policy, what I was able to do here is basically figure out what are the things that the CubeSystem components need. Now, I'll admit, when I first wrote this policy, I actually didn't realize Sysdig had the tool that they have to kind of auto-generate these, which is something I'll show you. But nonetheless, I kind of had to go through and audit and look through and figure out what are some of the policy things that I actually need to make this work. Well, I know that to make it work, I need host path access so that the API server can see its certs. I need config maps. I need the ability to run as any user, right? There's a couple different privileges in here that I do need. But unlike the permissive one, most of the CubeSystem components don't necessarily need the allow all capability. So I don't need to give it every capability in the world per se, okay? And I don't need to give it privileged true or anything like that. I can kind of scope down this CubeSystem policy and apply it to my pods. So let's start off by applying this policy, and we'll get deeper into kind of how everything's linked together. But let's just start by applying this. So I'm going to open up another window down here, all right, and we're going to do a watch on, okay, watch for kubectl get PSP. Looks good. All right, so let's apply it. So we'll do a kubectl apply, and we are going to apply policies inside of the CubeSystem namespace here, or sorry, not CubeSystem namespace. See, I'm already messing up the naming. Just calling it CubeSystem PSP, I'm going to apply this policy. All right. And now it has created the policy. One of the nice things about the get in the policy is it'll also give you kind of like a nice view of all the things you potentially have turned on inside of CubeSystem. All right. So I have flipped this on. Now, if we go back to the cluster for a moment, let's do another get pods, right? So we'll do a kubectl get pods for the namespace CubeSystem, and we'll set up a watch here. All right. So unfortunately, it's not what I was expecting, right? I was hoping that with the introduction of this policy, I would actually see the core DNS pod get created in here. Because based on everything I know about core DNS, the privileges you see here, I believe, should be adequate. Now, if you think about this for a moment, the PSP that you have here, this policy, is an object like anything else in Kubernetes. And in order for something to be able to use this policy, it needs to have the RBAC use verb attached to this specific policy. And if we think about it from our diagram earlier, I know it's a very, very ugly, rough diagram, but you get the idea. We know that it was the replica set controller, right, that was trying to go through the API server and create this pod, right? So what I effectively need to ensure is that the replica set controller is in fact able to go in and instantiate this pod based on what it's trying to do. So this is where RBAC is going to come in. And this is where these PSPs oftentimes get a little bit tricky. So if we go back to our PSP here, I am going to open up a policy, an RBAC file real quick. So we'll do policies, and then we will do the RBAC. So let's try that out. It is the CubeSystem PSP RBAC. Okay. Let's get rid of this one so it's easier for you all to see. All right. So with these policies come RBAC rules that allow you to use the policies themselves. So this is where it's going to get probably the most tricky. So bear with me here and ask questions in chat if it gets confusing, okay? So effectively what we're going to do here is we are going to set up a cluster role. A cluster role that we can attach to from role bindings in a namespace, or cluster role bindings that are cluster-wide, up to us. But it's a cluster role that can be reused nonetheless. And we're going to call this cluster role PSP CubeSystem. We are going to provide use access to the CubeSystem Pod security policy, all right? That's this PSP right down here. So by giving this use access, we are going to give that service account, whatever it might be, the ability to resolve it. Now, I had mentioned to you a little bit about these different service accounts. So what I'm going to do here is I'm going to provide a role binding. Okay, and again, role bindings are going to take the cluster role, and they're going to apply them on a namespace level to everything running in that namespace. So I have a bunch of things inside of system service accounts that I am going to give access to. So these system service accounts, if I kind of back up, let me just show you something in a big screen here. So if I do a kubectl get service accounts for the namespace CubeSystem, you can see here that we've got a bunch of service accounts for all these different controllers, right? Now, I can go in, instead of using the group that they're part of, which is system service accounts, I could go in and give specific service accounts access to this policy. I don't have to do all service accounts inside of CubeSystem. I could be very hyper specific. It would kind of look like this. I'd create a kind of user, and then my name would be something like the replica set controller. This way I could give just the replica set controller access. But in this case, I'm going to be a little lazy because I want the daemon set controller to be able to create pods. I want the replica set controller to be able to create pods, and so on, right? So let's get rid of that. All right. Now, there's another subject in here for system nodes. I'm going to talk a little bit about that at the end. All right. But I will show you kind of what this system nodes piece does in regards to mirror pods in a little bit. All right. All right. So we've got this role binding and we've got this cluster role inside of here. So I'm going to go ahead and save that up. Let's see if I can get out of these things I changed real quick. All right. If the error in the replica set events change. Sure thing. Yeah, sure thing, Wagner. I'll show you. So inside of this, if I do the let's do a describe. Let's do get replica set in the namespace CubeSystem. Okay. So we've got core DNS in here. And again, this will be a good reminder for all of us. If we do a describe on this replica set, the error is still just kind of looping. You can see it's happened 18 times over 17 minutes, right? It has constantly been trying to create the pod, and it never found a policy because this controller never was able to. So if I apply this RBAC, so the RBAC you just saw with the cluster role and the role binding in the cluster role. So we'll do apply of policies. and we will do the CubeSystem PSP RBAC inside of here. All right, and I'm going to go ahead before I hit enter here and open up another window. So let's go ahead and do a watch. Okay, for kubectl get pods in the namespace CubeSystem. All right, so it's inside of there. And now we can apply this RBAC, and these RBACs have now been created. So if all goes well in a moment here, once the replica set controller attempts to recreate that core DNS pod for me, I should see core DNS show back up here if all goes well. Now, it's probably on some amount of like circuit breaker type pattern, but we should effectively see it pop back up in not too long. So let's give it a couple minutes and see how it goes. So we've got that in place. We've got the PSP set up. Looks good. All right, and if we do another watch on the describe even, let's see if we can see this here. Okay, so 18 times over 19 minutes. So I should eventually see this increment to 19. So we'll keep an eye on this and see if it comes back to 19 in a moment here. All right. Okay, so while we're waiting for this, kind of thinking about it. So now we've got a CubeSystem pod security policy in place, right? And we're giving all the service accounts that might want to create pods. These are the daemon set controllers. These are the replica set controllers, perhaps stateful set controllers, whatever they might be. They're now theoretically allowed to create pods. Hopefully we'll see core DNS show up in a moment here too, right? Now, if we go in and think about our normal workloads, we probably don't want those standard workloads to be able to do the exact same thing, right? So in this case, we're going to want to think about doing something like a kind of default policy, if you will, all right? So I'm gonna check on that. I'm gonna check on that describe one more time. Let's see here. See if we get anything. Okay, so we're still at 18. It hasn't tried again. Let's give it a little bit more time. Hopefully it'll increment to 19 here and not too long. Actually, one way that I could prove it out too, to be completely honest, just in case the back off is going to take a while, let's try killing this other pod, and hopefully it works, or else we'll lose our DNS altogether, right? So if we do a kubectl delete pod, and we delete the core DNS pod in the CubeSystem namespace, okay? It'll delete that pod, and that triggered the replica set controller. Great. So now you can see two core DNS pods to actually go in and instantiate these pods and set them up. So pretty cool. Now these pods are able to run with that PSP. Now you might wonder, well, Josh, how the heck do I know that it's running with that PSP itself, right? How do I know it didn't just randomly start? Well, one way that we could validate it is we could select that pod and we could do a kubectl get pod namespace CubeSystem, the core DNS pod, and I can ask for the YAML output of that pod and put it through a less pipe here. So let's do that. Now, what's cool about this, if you look around, is inside of the annotations, you'll notice that with PSPs enabled, it'll actually tag via an annotation what PSP resolved against the pod itself, all right? So, this is kind of a cool thing for us to kind of sanity check and wonder, like, what exactly is the PSP that resolved? Was it CubeSystem? Was it another PSP? We know that this is, in fact, that policy, and we know that that is what was allowing the replica set controller to instantiate that new pod. So overall, pretty cool stuff. Okay. All right, and checking chat, Bogdan. Oh, -D with watch. Yeah, good call. I should use that. It'll help out with highlighting that stuff. Christopher from Germany. Hello, welcome. All right, so for those of you who are maybe just getting up to speed, where we're at right now is we've got pod security policies turned on. We've got the CubeSystem namespace that we're allowing specific pods to be created in. And now we want to go in and just add in kind of like a default PSP that we can use and make sure that everything's working correctly. So an interesting thing that I'll show you here, right? I told you, hey, you can have this more limited pod security policy. I'll show you that one more time. So you can have this more limited PSP. Let's go to TGIK. episode 078. Okay, we'll bring back policies here. Okay, so our policy is going to be the CubeSystem policy here. All right, good. Now, as you might remember, this CubeSystem policy was more limited than the full permissive one. And there are actually a couple pods that do need even more capabilities than CubeSystem does, particularly our networking pods. How do I know this? Well, effectively, check this out. If we take kubeproxy, which is running on our host, and we do a kubectl delete pod kubeproxy for the namespace CubeSystem, all right, I am going to be able to remove this pod, and it will not actually start back up again because that policy that I applied to CubeSystem, it's good for core DNS, it's good for some of these other pods, but it's actually not good. It's actually not good for the networking components because they require a little bit more privilege. So, thinking this through a little bit here, all right? If I come back to the policy, I've actually set up a separate policy for my networking stuff, okay? Because through examining my networking pods and things of that nature, I've started to realize, they have some additional rights they need. In particular, they need privilege, and they need to be able to have privilege escalation, right? They need to be able to bind to host network, which most of my stuff doesn't actually need in CubeSystem. So my preference is to lock down most of the CubeSystem components and have a special exception for my networking components themselves, right? So same idea here, just like you learned before. We know we need another policy, and we can validate this if we go into kubectl get daemon set, all right? And we get the daemon set for, let's see, so daemon set for CubeSystem, all right? Get daemon set, CubeSystem, let's see what we got here. So we've got kubeproxy. All right, let's see what's going on with kubeproxies. Clearly something's up. So not the replica set controller, but the daemon set controller is blocked from being able to instantiate it. So when we think about our terribly ugly diagram here, right, we'll open up another one. And now the situation that we're in here is the, let's just say DS controller, and we'll call this the RS controller for short. Really same idea though, right? We have the API server, it's validating. We know that this first one is good, this one's fine, and we know that this new one is not good because it is not able to find something where it has the privilege escalation and the host networking capabilities, right? So we need to basically do the exact same thing we did before. Let's go in and let's apply that policy. So again, I am going to, vim into that for a moment here. So we've got CubeSystem. Let's do the networking PSP. All right. Bring this down a little bit. Okay. And let's do a watch. And we'll add -d in since I never knew that you could do -d. That's really cool. So watch -d, and we'll do a kubectl get pods namespace, get PSP, no namespace. Great. So we've got the PSP inside of here. All right. So let's look at our PSP one more time. The big changes here is we're going to introduce a new PSP called networking. And its primary differences is that it is going to be allowed for allow privilege escalation, and for host networking, for our networking-oriented components. So in particular, this is going to be applicable for Calico and kubeproxy, all right? So let's see if we can apply this now. So we'll do a kubectl apply for the networking PSP. So we'll do policies, networking, PSP YAML. All right, so that's created. And awesome, I just saw our highlighted change shoot up. That was very cool, all right? So if we look inside of this, this PSP, things are looking good. But if we go back to the actual things that are running, let's pop back real quick. So we'll go and say a kubectl get pods namespace CubeSystem. Again, we have to keep in mind that adding the PSP is not going to be enough to make the extra kubeproxy come in. It's still being blocked by the daemon set, right? And if we do a kubectl get daemon set, and Bogdan, this is, I think, kind of going towards your question. If we go to get the daemon set for kubeproxy here, let's go ahead and describe it. Okay. All right, let's see if I can describe daemon set. The daemon set's name is kubeproxy. That's the pod. All right, so we have the same thing going on. Failed to create, forbidden. Now, what's cool about this time is since we have a policy in place, it actually is going to tell us kind of the delta that we have going on, right? And to your point, Bogdan, yeah, with the daemon set, exactly. So this is key, right? It's actually going to be able to say, hey, I looked and saw the policies you have, but you're asking for privileged containers. And that is one of the things that you're asking for too much. And I am going to block you because the existing policies, none of them are going to allow this particular thing to start up, right? So we're being blocked because of that privileged call, which is great. That's actually really good. We've limited the scope of our PSPs here. If we do a get pods one more time, okay, clear that out. We've limited the scope of the privileged containers to just Calico node and kubeproxy. But as you know, to make this work, we need proper RBAC in place, or else kubeproxy will never be recreated. So what does that mean? Now, before, if we go back to, let's go back to the CubeSystem, general PSP for CubeSystem, right? If I go back and I say, we'll do policies, we'll do CubeSystem PSP, all right? Let me, sorry, actually, I meant to do, bear with me here, CubeSystem RBAC is what I meant. Oh, and I just applied it. Okay, so let's see if we can do the right command here. How's that sound? Okay, so E, great. All right, so this is CubeSystem. This is not the networking policy. This is the CubeSystem policy that's already applied. Remember that the role binding we gave it is we said, hey, any service account that lives in the namespace CubeSystem, you can use this policy, you can instantiate pods, all right? So that's great, but we don't want to do this for networking, right? For networking, we want to know, hey, I want to make sure Calico node only sees this, and I want to make sure kubeproxy only sees this, right? And how can we do that? Well, if we go back to our cluster for a moment, and we do a kubectl get service accounts, all right? And we grep for Calico, or sorry, if we, let's see here, if we get service account, sorry, for the namespace. So again, all these namespace scoping things can get you. So kubectl get service account for the namespace CubeSystem. Let's see if we, okay, we got results there, good deal. Now, if I search for Calico, there is a Calico node service account. If I search for kubeproxy, there is a kubeproxy service account. This is a good thing. What it means is we can give that networking PSP exclusive access to these two service accounts so that when the pod comes online, while the replica set controller might not be able to create it, because its service account is bound to the PSP, we're basically going to be able to make an exception for these particular components. So what does that mean in the RBAC standpoint? So let's open this up. If we go to policies, okay, and then we do the the networking RBAC, all right, we've got this cluster role, which is just like the one you saw before, except it's pointed to PSP networking. It's going to allow us to use the networking PSP. And then we've got this new role binding, and you'll notice that the kind, and I think I might have said user earlier, I was mistaken there. The kind is service account in this case. So we are going to allow the Calico node service account in the kubeproxy service account in the CubeSystem namespace to be able to resolve this pod security policy and only this pod security policy. Well, actually, technically, this guy can also, these service accounts also could theoretically use the CubeSystem policy, but we know that that policy is not good enough because it doesn't give privileged access and things like that. All right. So let's see if we can test this out now. So if we do a kubectl apply and we do the networking here, so we'll do policies, networking RBAC. Cool. So we've got networking RBAC in place, and if I apply that, okay, we've got the PSP networking unchanged, looks good, which might have mean I applied it earlier. So let's see if we can figure this out. So All right, let's see here. If we do a kubectl get PSP, just want to make sure those are there. So we've got CubeSystem and networking. Looks good. Now, if we do a kubectl get daemon sets for the namespace CubeSystem, awesome. This is looking much better. So theoretically, kubeproxy picked it up and now has 2 that are available. Let's check the actual the events again, just to make sure we've got a good grasp on this. So if we describe, okay, so we'll do a describe on the kubeproxy daemon set inside of CubeSystem. Okay, describe daemon set kubeproxy. Awesome. So you can see the warnings that looped 16 times on the daemon set. And then at some point, I apparently accidentally applied the manifest when I was testing things out, because you can see the gap there in minutes from 7 minutes to 4 minutes. But now it is actually resolving that. So it is found that service account. It is resolved against that PSP. And now if we go back and do a get pods for CubeSystem, we now have 2 kube proxies that are in place. So you've now seen 2 levels of things. We've given, in the CubeSystem namespace, full access to a specific set of pods, if you will, that run in networking, that need extra privileged capabilities. We've given another set of permissive privileges to the just general CubeSystem pods that don't need all that access. Maybe there's like, I don't know, maybe like metrics server or something, or some I guess something that's running as a pod in your system, more or less, is going to be running in here, and it can resolve the CubeSystem pod. And Core DNS was one of those. We didn't need the full-on privileged access and so on inside of Core DNS. So kubeproxy is resolving against the PSP for networking, and we can validate that easily. So kubectl get pod, we'll do o-yaml, and if we search for PSP, we can see that it is resolving the PSP one. All right. And if we go back to the let's say, what was it? Core DNS, right? If we go back to Core DNS and basically do the same thing with Core DNS. So we will look for PSP. Hopefully, let's see here. Get pods, CubeSystem. Oh, I had to watch there. Sorry. There we go. Core DNS. Oh, you know what? I think only one of them started with the PSP. Let's see here. So if I get the pods for CubeSystem, let's see here. I have 2 Core DNSs. I'm not sure which one had the PSP. So kubectl get pod. Nope, that one didn't. Let's see here. This one have it? Huh, interesting. So for some reason, my Core DNS pods don't have the PSP on them anymore, which is super weird. So pod Core DNS, namespace CubeSystem, and then let's do a o-yaml on that. Okay. PSP in the annotations. Oh, it's there. Huh, I wonder what I was doing with my search. Sorry. Anyways, so the CubeSystem for Core DNS was not actually, not resolving networking, but it was resolving the CubeSystem PSP. All right. Cool. All right. Sorry, I've been looking away from chat here. Yes. So around policy orders, I think Duffy had kind of hit on that there, that it's alphabetical in the first match wins. So that's a very important point, right? All these pods need when they get created is they need the account that creates them, or their service account, needs to have at least one policy that satisfies the things that they are asking for. And it will look alphabetically, find the first one, and then boom, it takes on that policy. Because at the end of the day, which policy got chosen doesn't matter a ton. I mean, it is important because you want to make sure you have the right policies falling in place. But at the end of the day, if a policy satisfies it, the pod's allowed to be created. That's your gate. And that's why checking for this annotation is helpful, because it will ensure that you have the correct policy in place that you were expecting it to resolve against. All right. Okay. So I see some questions about a base PSP, and that is kind of the last thing we haven't gotten to here. So let's talk a little bit about what a base PSP would look like. So backing up a little bit, we have a couple namespaces, right? We have our CubeSystem namespace. But we have a bunch of other namespaces that our company, our hypothetical company, is using. Lines, mountains, org1, org2, ping, so on and so forth. And so far, none of these other namespaces are going to be able to have the privileges they need to actually create pods, okay? So what we need is some kind of default policy that's going to provide us with the ability to effectively instantiate pods as just normal workloads with kind of some sensible defaults, okay? So in this example, and this will all be in the TGIK GitHub too for this episode. In this example, I have a policy. Let me go ahead and show you that. So CD policies, all right. I have a policy called default PSP. Now, default PSP is quite a bit different than the other ones. For the most part, and you can ignore these annotations, I was just playing with them earlier, but for the most part in the spec, it has a bunch of what I would consider to be sensible defaults about what I want standard workloads to be able to use, okay? So, first off, I want all capabilities to be dropped by default. I don't want any additional Linux caps to be available to me. I've got a set of volumes in here that I'm going to allow the workloads to use. I'm going to allow them to get secrets, config maps, obviously secrets that they have RBAC access to, persistent volume claims, but I'm not going to give them host path and different things like that. One really strict thing is I'm no longer going to let them run as root. So people who come onto my cluster, they're going to have a non-root user running in their containers, hoping to prevent random privilege escalation things or similar vulnerabilities that might pop up that root users might be able to expose and access. Same goes for groups. Same goes for different parameters inside of here. So the default one, and you might want to tune this to your own organizational needs, is going to be what policy can always be resolved. Always. No matter what, this policy can be resolved. All right? So I'll show you kind of how we achieve that. And we'll start off by setting up another watch down here. So let's do a watch for, okay, a watch. And again, -D. I got to get used to that. A pretty cool trick. kubectl get PSP. All right, so we've got CubeSystem and we've got networking. Okay, so I'm going to apply the default PSP YAML file here. Okay, and I'm going to hopefully do apply correctly with -F. There we go. All right, so now this has changed and we have got the default policy that is now in place. And this is, again, what we're going to use. But again, the thing to keep in mind, this policy is useless right now. We need to have a role binding or cluster role binding to allow people to, or accounts rather, to see this service, or sorry, to see this policy, right? So just like everything else in this policies folder, I have a default RBAC YAML file to show you. All right. Now you're kind of getting used to the cluster role. All the bindings to the pod security policies, I just have cluster roles here, right? I'm going to say you can use the default pod security policy. Use default pod security policy. Now here's how I made this the default. Instead of using a role binding, which is going to give access to a PSP on a namespace level for service accounts and things like that, I'm going to use a cluster role binding, right? I'm going to use a cluster role binding here. So with the cluster role binding, I'm going to call this PSP default. And effectively what I'm going to say here is I am going to say anything that is system authenticated can see this PSP, all right? Now you still have to have abilities to create pods, you still have to have abilities to create deployments, so on and so forth. But if you are authenticated and authorized, again, remembering that you've gotten past this first step in our chain of the API server, you've auth-ed, you've auth-z'd, now we are going to let you see this default PSP always, whether you're in CubeSystem, default namespace, or any other namespace. All right, so let's go ahead and apply that inside of here. So we'll do a kubectl apply, okay, apply F, and let's see, so this is default RBAC, let's say default RBAC, and put that in place. Awesome, okay. Our default PSP is set up. So let's see what this means for our users. If we backpedal to the beginning of this video, right? In the beginning of this video, I was showing you this application called the app pod, if you will, right? Team A rather, Team A pod. Now, I'm going to start running this as a deployment going forward because most of the time that we'll be creating deployments, and I want to show you what a deployment goes through as far as the authentication authorization goes for and the admission control. But again, just to note that the same thing applies for me as a user. I, as a user, need permissions to create this pod. So assuming I get through authentication and authorization, I could also still create this pod, and it could theoretically resolve against default. Okay. Or at least attempt to resolve against default, as you'll see. Now I'm going to change this just a little bit to something called app.deploy, or sorry, app-deploy. It's really no different except I've wrapped your container in the bottom here, your pod. I've wrapped that in a deployment, okay? So we are going to deploy 3 replicas of our pod Nginx, all right? And that is hopefully going against the default PSP, okay? All right, so let's see if we can do that real quick. So I'm going to open up, again, actually I'll do it in this window, make it a little bit cleaner. So, okay, we will go down. Okay. All right, so kubectl get pods for the namespace org1, which is where these workloads are going to run. We'll do a watch-d. There we go, good deal. All right, let's apply this deployment and see what happens. So kubectl apply f the app deploy YAML. All right, so we have a bunch of container creating, and then if you see inside of here, we're getting a create container config error, which if my memory serves correctly, it didn't always provide you this, and this is such a nice convenience because back in the day, again, unless my memory is serving me incorrectly, you just wouldn't see a pod here. And then you'd have to go into your deployment, go into your replica set and figure out why things are in fact breaking, right? So let's figure out why this is breaking. Because again, we should have been able to resolve against the default PSP. So I'll go back. And again, based on our diagram, I did a deployment, right? So we know it's going through this chain of command. There's a replica set controller that is trying to instantiate the pod, and it is clearly not finding a PSP. All right, so let's figure out why. We will exit here, and we are going to do a kubectl get replica sets for the namespace org1. All right, so we've got 3 current but 0 ready replica sets. Let's see if we can figure out what's going on with this app. Now, with the config error, I should have actually been able to go into the pod too, but I'm just going to keep it consistent here and describe the replica set that you've got here. So replica set, good. Oh, and sorry, I guess it actually is, the flow has changed a little bit, I think, unless I'm mistaken. So I guess I do have to go to the actual pod because it kind of creates the pod itself, and then in the pod, it should tell me about why it failed. So let's see if we can figure that out real quick. So we'll do a kubectl describe pod, right? Again, in the namespace org1. All right, this is what I'm looking for. So interesting. Okay, so it's in the pod, which I actually think is a bit of a better user experience from at least what I was recalling. In the pod, it's saying, hey, trying to create this, but your container has run as non-root, or sorry, your PSP has run as non-root, and the image will run as root. So our PSPs are actually doing what we want them to here. If we go back to our deployment, the app deploy, this Nginx image is running as root. So our PSP is doing its job and actually blocking us here, which is pretty cool. So what do? Well, suddenly we realize, okay, are we willing to let Nginx run as a root user? Is that okay with us? And let's assume for a moment that it's not. So we go back to our app teams and we say, hey, you have to find a container image that's not running as root, or you need to select this. So if you go into the Kubernetes Docs, there is an area that you can go into called security context. Okay. And if you look up security context, you'll actually have ways to specify who you're going to run this particular pod as, which can be helpful. So if there's multiple choices, perhaps it's not just a root user, it's just selecting root by default, right? And you want to run as some other user. Now in the Nginx image, I actually would prefer to use an image that runs as non-root by default. So by doing some Googling, and I won't waste your time Googling Docker Hub right now, but I found out that Bitnami has now part of VMware actually, but it's just connecting now. But nonetheless, Bitnami has images that are blessed and a little bit more a little bit more security minded. I hope that's okay to say. But basically, the Bitnami image I read about actually runs as non-root by default. So if I change my image to Bitnami Nginx rather than just running Nginx, as long as the docs for the Bitnami Nginx container are correct, it should be able to run this as a non-root user. So I'll save this up. Okay. We will do a kubectl apply. All right. Actually, let's go back to this one here. So we'll vim in to app deploy. Let's set up a watch for pods. All right, so we've still got these pods that are broken. Make sure I have Bitnami here. Yep, Bitnami is in fact set. So we will do a kubectl apply and do the app deploy.yaml. All right. And then apply that in. And now you can see some of these things in watch are starting to change and they're starting to churn against this default PSP. And boom, we have officially got running pods. Pretty cool stuff. And again, trying to keep in mind what we learned, we should now be able to do a kubectl get pod, this app, inside of the namespace org1. All right. And in org1, we can ask for OYAML, and then I will AG for the PSP. And you can see that it in fact resolved the default PSP. All right. So again, now we've got this blanket default PSP. It runs everywhere. It'll block anything that we need it to block and so on. And that's it. Really, really cool stuff. So just kind of to summarize here, and there's a couple kind of tips and tricks and a couple more things I want to leave you all with, just to hopefully no more than 10 or 15 more minutes of content here. So if we look at this, we've got our PSPs, right? And our PSPs are a CubeSystem PSP, right? We have a networking PSP, and the networking PSP is very, very high privileges and so on. And then we've got a default PSP that's going to run on anything in the cluster that we want to resolve, right? The CubeSystem PSP is bound to system service accounts, okay? System service accounts inside of the CubeSystem namespace, all right? So open that up a little bit, all right? So in CubeSystem, networking is bound to the Calico node and Cube proxy in CubeSystem, okay? And then default is basically set up to everything, right? So we've got these different levels of resolution. Now, the last thing that I kind of want to leave you with here, and then I'll show you PSP Advisor real quick, is how do you provide exceptions, right? So you're going to run into this case where an app team is going to call you up and say, listen, I can't change this thing. I need my workload to have an exception. I can't just be beholden to the default PSP itself, right? So there's a couple ways that you can approach this, right? So you might have situations where you either want to provide a, let's call them exception PSPs, right? Exception PSPs. And you might want to do them on a workload level, or you might want to do them on a namespace level, okay? And this is where PSPs also get a little bit tricky. You have these two options. You could have a namespace called system components, right? And you know, it's gonna effectively it's gonna effectively want namespace level access to these, kind of like CubeSystem. CubeSystem's not too different. With CubeSystem, that's effectively what we did. We set up a role binding for all the service accounts, right? And we said, hey, you should be able to resolve this if you're a service account inside of CubeSystem. But effectively, we may also want to provide these workload level exceptions, which would basically mean that if we want to go back here, right, and we want to go back and go to our app, and we want to run Nginx latest again, and our app team says, there's no way we're not going to run this thing, okay? So let's go ahead and get it in that state real quick. So we'll apply this deployment, okay? It'll start recreating and then once again fail. Now, probably what we'd need to tell our app team to do is that we need to tell our app team that we want them to set up a service account dedicated to the Nginx controller, okay? But for the time being, we're just going to give a extra privilege capability to the Nginx workload here, all right? So if I go back into my policies, okay, and then we go to the default PSP for a moment here. So here's what I'm actually going to do. Let's back out. We'll exit out of here. All right, and we will go into TGIK episode 078. Cool. Oh, and yes, and I will definitely show the sysdig thing as our last little thing, by the way. So don't worry. I promise I haven't forgotten that. So inside of 078, I'm going to go to policies. All right, and I'm going to start off by just copying the default policy. Okay, default PSP. And I'm going to call this, this is a terrible name. Let's call it extra PSP, all right? So extra PSP. And inside of the extra PSP, we are going to change one thing about it. We are going to allow users to run as any, all right? So run as any user. We're going to make an exception for this team, all right? Cool. Now, if we go back, I am going to, I probably should name it correctly too. So extra PSP, we're going to call this guy the extra PSP. Okay, good deal. Now let's apply extra PSP here. So if we do a kubectl apply extra PSP. All right, extra PSP was created. Okay, we do a kubectl get PSPs. We've now got default, extra, CubeSystem, and networking. Now, again, all of this happens, all the magic here happens in RBAC. So if we copy over our, I'm going to copy over a different policy, actually. We'll copy the CubeSystem Actually, let's copy over the default RBAC here. So default RBAC, and we're going to call this extra RBAC.yaml. Okay, so extra RBAC. Awesome, all right. So let's change a couple things about this. So extra, I'm gonna call it extra. Again, these namings are terrible. It's just for the sake of time. Extra, all right. And then what I'm gonna provide here is I'm gonna provide access for the service account. And that service account is going to be the default service account, all right? Okay, and this is actually going to be a role binding here. So we're gonna do a role binding, okay? The namespace of this role binding is going to be the org1 namespace. Okay, that's where we're at. So org1. We'll take namespace out of here. Looks good. The cluster role that we're going to reference is going to be, I think it was called extra PSP. So hopefully I've got that name right, and we'll call that extra PSP, right? So role ref, the role ref, which would be this. So PSP default extra. Let's see if we can find this here. So PSP default extra, all right? So we'll do a kubectl get PSP, make sure I've got that right, extra dash PSP. Okay, so that's good for the resource name. Extra dash PSP is the cluster role, the pod security policy. The cluster role is PSP default extra, which we're referencing down here. All of that overall looks pretty darn good. Okay. And yeah, so org1 namespace. At a conceptual level, it looks correct. I'm always worried about trying to write RBAC really fast like this, but let's see what happens. So we'll troubleshoot it if need be. So kubectl apply extra RBAC, right? So I have created that role binding and role, cluster role and role binding. Cool, looks good. And then if we go back to our deployment, let's see if it's still breaking on us. We probably can debug this if it's still giving us issues. So I will delete the app-deploy. Okay, terminating. Get rid of all that just for, again, refreshing ourselves and get rid of the potential circuit breaker back off that might be happening. Let's apply app.deploy again. Delete, apply this time, is what I meant. Pending, all right. All right, so we've still got a container create error here. Let's see if we can find out where in our PSPs here we've gone wrong. So org1 namespace. The service account name is the default service account. It all seems okay. PSP default extra looks good. Let's see here. Let's see if we can find this real quick. So get service account inside of default. So the service account is called default. That seems to be what it's using. So service account default. Okay. And I wonder, actually, let's see here. I wonder if I explicitly have to call out the service account for any reason. org1 service account default. Okay. Let's see here. So if we check this out here, Kubernetes service account. Just going to try to get a quick YAML if I can here. So service accounts for pods. Let's see. Service account. There it is, right inside a spec. Okay, let's see if we can make this really quickly here. So cool. So inside of the spec for the pod, I'm just going to go right here. Service account name is default. Okay. Yeah. Oh yeah, actually good call, Rory. I think you might be right. I think we are blocking the group. Let's check that right now. I think you are correct. Let's double check. So what I should have done here, which is effectively what I told you all to do, I should have gone ahead and checked the actual error message. So let's try that real quick. So org1. All right. So if we do, let's see here if I make it a little bit bigger. So, okay, clear. So if we do the kubectl get that, all right, and we do the actually I'm gonna do a describe here. So kubectl describe the pod app1. Have a feeling where you're correct on this one. Let's see. Oops, sorry, getting my commands mixed up now. So describe pod inside of org1. Error container run as non-root. Image will run as root. Now it seems to say the same thing, but I wonder if that's still a thing. So here's something we can do to just prevent it potentially being something silly with the PSP I made. Now, not that I'd recommend that you do this, but let's go ahead and give it the role ref to the actual CubeSystem one, which we know has far more heightened privileges, right? So we'll do PSP CubeSystem here and see if that happens to fix it, and that might validate what Rory said in there too. So I'm just going to do a quick split and make sure my my CubeSystem RBAC is what I think it is. So the name is PSP CubeSystem. PSP CubeSystem. Overall, it looks pretty good to me. Let's see if we can apply that then. So kubectl apply the default, what was it called here? Extra RBAC, right? Authorization group cannot change role ref. Okay. So RBAC's getting to me here. So we'll delete that. We'll apply it again. Okay, created. All right, let's see if we have any different results here. If not, I might need to troubleshoot offline and get back to you. So kubectl get pods inside of the namespace org1. Okay, so let's go ahead and kubectl delete the app namespace. So this is app deploy. Okay, and let's set up our watch down here again. Cool, so org1. All right, so kubectl apply deploy app1 deploy. Okay, let's see if we have any better luck here if it still blows up on us. Yay, here we go. Okay, so I would be willing to bet, Rory, that you were probably correct. The message wasn't much better for me, but to his point, I believe what was going on here is the RBAC for our what was it called? The extra PSP, right? So I am allowing it to run as any user, but I'd be willing to bet you that this guy needs to allow the root group. And in fact, we know for a fact it has to, because without the root group, you're not going to be running as root. So that's almost guaranteed exactly what blew me up. So I just kind of tied it into the CubeSystem one for testing purposes. And sure enough, we're able to create it without any issue at all. All right, so we've gone fairly over on time. I appreciate you all sticking around and all the awesome questions and comments in the chat. I want to show PSP Advisor off real quick. So you saw me showing off tons and tons and tons of these policies and playing around with them. And you just saw how easy they are to screw up. In fact, it's almost like I'm trying to sell you PSP Advisor right now, right? Literally, I messed it up. And if I had used PSP Advisor, I may have been able to prevent that. So basically, PSP Advisor is a open source project that's in the Sysdig Labs repository. It looks like Duffy put it in chat. So those of you who are still with us, you can check out the chat down there. But basically, you can clone this down. It's a really, really simple binary. And what's great about it is not only will it give you an idea of some PSPs you can start off with, but it's actually, in my opinion, an awesome auditing tool. The ability to go, what's running in my namespace? So after this session, some of you should just go into your clusters and try running this and see what results you get. So basically, I have a binary. It's called kubepsp advisor on my system. All right. And kubepsp advisor, if we look into the help real quick, is going to provide me with the ability to give a namespace, right? So if I do this here, namespace, and I can do it for the whole cluster, but I think namespace kind of scopes it a little bit better. Let's start off by doing it for org1. Sorry, I'm used to the Kubernetes conventions here. Namespace org1, all right? So the pod security policy that it has for org1 is it's basically telling me, hey, your file system group needs to run as any user. So if I had taken PSP Advisor's advice, PSP Advisor is not necessarily saying you should use this as your policy for the default namespace, but it is telling me, based on your workloads, you need this to be set or it won't work. You also need this to be set or it won't work. Now, here's a really cool example. Let's look at CubeSystem. So if we take the namespace CubeSystem inside of here, it is going to analyze all my workloads once again. And notice how granular this gets. It allows host paths, which is what mine does, but it's actually going to take every single one of the paths that my workloads are using. So things like CA certificates. And it's going to make sure that that workload has read-only access to that particular path. I can also see that I have some workloads running host network and privileged. So that is a really, really cool thing inside of here. I would say, the only thing I'd be careful with PSP Advisor that maybe there's a way around this and the Sysdig folks can help out if so. But, if I took this at face value, it is going to give certain workloads more privileges than I need because it's analyzing what's being used at a namespace level. So what I'm getting at here is if we go back to CubeSystem, so kubectl get pods namespace CubeSystem, like I had mentioned, PSP Advisor is saying, hey, you have workloads that need host network and privileged. But on a technical level, only kubeproxy and Calico Node need that, right? So nonetheless, that's not to down PSP Advisor. This is an amazing, amazing place to start, an amazing place to audit how things work, and it should be a really good starting point. So all you would need is to run PSP Advisor, get some outputs, maybe massage them a little bit, and then all you're doing is setting up RBAC that allows certain service accounts to utilize this particular pod security policy. So if it were me, I would honestly take this output, massage it a bit, and I would use it instead of the CubeSystem policy that I showed you today, because I think this is a far better, more descriptive policy. All right. So that's PSPs. Frankly, it's a lot of information. And if you're still a little bit confused by it, you're probably doing better than I was, because it took me a really long time to wrap my head around some of these concepts. Really, really appreciate you all sticking around and being encouraging. Hopefully this wasn't too much of a brain dump on you. But yeah, again, this was our PSP session. You can find me on Twitter at Josh Rosso. I would love feedback, both positive and negative. So, throw it at me. And if you have additional questions, hit up Duffy, hit up myself. We love this stuff. We love talking about it and making people more aware of it. So please shoot us a message on Twitter and we'll do our best to answer it for you. All right, everyone. Thanks again. It's It's been a pleasure. And until next time, we'll see you soon. Bye.